Supernovae are among the most awe-inspiring and powerful events in the universe, captivating both astronomers and stargazers with their brilliance and destructive beauty. One star that holds the potential to offer a front-row view of such a celestial spectacle is Betelgeuse, the red supergiant located on the shoulder of the Orion constellation. This luminous and enigmatic star, renowned for its fiery glow in the night sky, has reached the twilight of its stellar life. Astronomers have long observed Betelgeuse with a mix of fascination and anticipation, knowing that its eventual fate is to collapse in a spectacular supernova explosion. This anticipation grew significantly in late 2019 when Betelgeuse began an unexpected and dramatic dimming event. For several months, its light faded so noticeably that even casual observers could see the difference with the naked eye. The dimming sparked concerns within the astronomical community, leading to speculation that the star might be nearing the end of its life cycle. Although Betelgeuse later regained its usual brightness, closer observations with powerful telescopes revealed that this was no ordinary fluctuation, it was a significant event, suggesting profound changes in the star's structure and behavior. Betelgeuse, also known as Alpha Orionis, is not just any star. This ruby-red beacon, perched prominently on Orion's shoulder, is the second brightest star in the constellation, trailing only the blue supergiant Rigel. Despite being slightly outshone by Rigel, Betelgeuse commands attention for its colossal size, its pulsating variability, and the historical intrigue surrounding its name and nature. The star is a cornerstone of celestial studies, often noted for its unique characteristics that set it apart from other bright stars in the sky. Its deep reddish hue and flickering brightness make it an object of fascination for amateur astronomers and scientists alike. Betelgeuse ranks as the 10th brightest star visible from Earth and is particularly prominent from regions across North America, Europe, and Canada. It has dazzled observers for centuries, becoming an emblem of the night sky's grandeur and mystery. The origins of Betelgeuse's name trace back to the Arabic phrase Yad al-Jawza, meaning the armpit of the giant, a poetic nod to its position within the Orion constellation. While astronomers estimate its distance from Earth to be between 430 and 724 light-years, the precise measurement remains a subject of debate due to the complexities of interstellar measurements. Nevertheless, Betelgeuse is recognized as the closest and brightest red supergiant visible from Earth, an extraordinary distinction given that only about 200 red supergiants have been identified in our galaxy. This scarcity amplifies the importance of Betelgeuse as a cosmic laboratory for understanding the life cycles of massive stars. The star's immense scale is almost unimaginable. It is approximately 764 times the radius of our Sun and emits a luminosity 126,000 times greater. Yet, its surface temperature is much cooler, registering at around 3,600 Kelvin, compared to the Sun's 5,778 Kelvin. Intriguingly, even if human eyes could detect light across all wavelengths, only about 13% of Betelgeuse's radiant energy would appear as visible light, a testament to its complex and varied emissions. The sheer size of Betelgeuse is awe-inspiring. If it were to replace the Sun in our solar system, its edges would extend far beyond the asteroid belt, potentially engulfing Jupiter. This vast expanse highlights its classification as a red supergiant, a type of star that experiences significant mass loss over its lifetime. Betelgeuse ejects material through powerful stellar winds, shedding approximately 1 solar mass every 10,000 years. This expelled matter forms a nebula spanning 30 astronomical units minus 30 times the distance between the Earth and the Sun. Surrounding this immense star is an even larger envelope of material, roughly 250 times its size, adding to the grandeur of this celestial giant. At its core, Betelgeuse undergoes the relentless processes of nuclear fusion that drive its evolution. Initially, hydrogen fuses into helium, releasing vast amounts of energy in the form of light and heat. As the hydrogen depletes, helium begins to fuse into carbon, and later heavier elements such as neon and iron form. However, unlike earlier stages of fusion, the fusion of iron absorbs rather than releases energy, leading to a catastrophic collapse under the star's immense gravity. This process culminates in a supernova explosion, an event so powerful it can outshine entire galaxies and radiate more energy in a single moment than our Sun will emit over its entire lifetime. Such explosions are among the universe's most dramatic phenomena, offering invaluable insights into the forces shaping the cosmos. The history of Betelgeuse is as fascinating as its current behavior. Ancient Greek astronomer Ptolemy described it as ruddy in color, a characteristic that endures today. However, Chinese astronomers from centuries ago noted that Betelgeuse appeared yellow, suggesting that it may have once been a yellow supergiant before evolving into its current state. Such transformations are a natural part of a star's life cycle, as stars change color and temperature depending on their stage of evolution. Massive stars like Betelgeuse burn through their hydrogen fuel at an accelerated rate, resulting in lifespans far shorter than smaller stars like our Sun. While the Sun, at about 5 billion years old, is in its midlife, Betelgeuse, despite being only around 10 million years old, is nearing its final act. Betelgeuse's fluctuating brightness adds to its allure. The star exhibits two distinct dimming and brightening cycles, one lasting around 100 days and another occurring every 5 years. These changes are thought to result from the expansion and contraction of the star's outer layers, which alter its diameter and temperature. In recent years, particularly during the dramatic dimming events of 2019 and 2020, these cycles have drawn significant scientific attention. While Betelgeuse returned to its typical brightness, the unusual dimming may signal that the star is approaching the final stages of its life, making it a potential candidate for a supernova explosion in the near or far future. Betelgeuse's journey is a testament to the dynamic nature of stars and the mysteries of stellar evolution. Its origins trace back to the Orion OB1 association, a group of stars born together in the same molecular cloud. Today, Betelgeuse travels through interstellar space at a staggering speed of 30 kilometers per second, creating a bow shock that spans over 4 light years. Measuring the size and age of this red supergiant is a challenging task due to its pulsations and varying emissions. Nevertheless, the study of Betelgeuse continues to intrigue astronomers, offering a glimpse into the vast processes of stellar life cycles and the immense forces shaping the universe. As Betelgeuse approaches the end of its stellar life, it remains a source of endless fascination. Whether it explodes tomorrow, in a decade, or thousands of years from now, its ultimate fate will be a spectacular display of the universe's power and beauty, reminding humanity of our small place within its grand and mysterious expanse. Here is an expanded version of the text, providing additional context and details for a richer understanding. Betelgeuse, one of the most famous red supergiants in the night sky, continues to captivate astronomers with its enigmatic behavior and complex characteristics. Central to this intrigue is the circumstellar envelope CSE surrounding Betelgeuse, a vast region composed of ejected material. This debris, which both emits and absorbs light, creates significant challenges for scientists attempting to pinpoint the precise size and structure of the star's photosphere, the visible surface layer of the star. This dynamic and ever-changing envelope adds layers of complexity to an already difficult task. Yet, despite these hurdles, astronomers remain steadfast in their pursuit of uncovering Betelgeuse's secrets. Every discovery brings us closer to understanding not just this individual star, but also the life cycles of massive stellar giants. One of the challenges in studying Betelgeuse lies in the variability of its observed size across different wavelengths of light. The star's apparent diameter can fluctuate dramatically, with reported measurements differing by as much as 30 to 35% depending on the wavelength used for observation. This variability highlights the difficulty in forming a consistent model of Betelgeuse's structure. A groundbreaking observation occurred in 2009 when the European Southern Observatory used the Very Large Telescope Interferometer VLTI to capture detailed images of the star. These observations revealed a massive plume of gas extending outward from Betelgeuse to a distance of approximately 30 astronomical units out, the equivalent of the distance between the Sun and Neptune. This extraordinary mass ejection was just one of several observed phenomena in the star's atmosphere, emphasizing its dynamic and volatile nature. Further studies have revealed that Betelgeuse is surrounded by at least 6 distinct shells of material, remnants of previous mass ejections. These shells provide critical insights into the processes driving mass loss in the later stages of a star's life. Understanding this phenomenon is crucial for piecing together the life cycle of massive stars and their eventual demise as supernovae. Such mass loss has implications far beyond the individual star, as it plays a significant role in shaping galaxies by redistributing elements and contributing to the interstellar medium. The complex interplay between a star's mass loss and its ultimate fate fascinates astronomers, and recent advances in interferometric techniques hold promise for unlocking more of these mysteries. A particularly striking event occurred in 2019 when Betelgeuse underwent a dramatic surface mass ejection (SME). Telescopes, including the Hubble Space Telescope, captured evidence of the star shedding a significant portion of its visible surface. This event, unprecedented in its scale and nature, involved the release of material 400 billion times the mass of a typical solar coronal mass ejection CME. The SME had a profound impact on the star's brightness, causing it to dim significantly. Between October 2019 and mid-February 2020, Betelgeuse's magnitude dropped from 0.5 to 1.7, sparking widespread speculation about its future. Some observers wondered if the dimming signaled the star's impending supernova explosion. However, detailed analysis ruled out core collapse as the cause, as there were no detectable changes in the infrared spectrum.